Halina mga bata, tayo nang mag-aral. Sa math walang maiiwan, at sayang mag-aral tayo nang matuto, upang ika'y umasenso. Maging matyaga, maging matalino, halina mag-aral na tayo. Maging matyaga, maging matalino, halina mag-aral na tayo. Halina mag-aral na tayo. Halina, 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 mag-aral na tayo. Halina mga bata, tayo nang mag-aral. Sa math, walang maiiwan. Matsayang mag-aral, tayo nang matuto upang ika'y umasenso. Maging matyaga, maging matalino, halina't mag-aral na tayo. Maging matyaga, maging matalino, halina't mag-aral na tayo. Halina mag-aral na tayo. Halina, 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 mag-aral na tayo.
Magandang araw pong muli sa ating lahat. Maraming salamat po sa lahat ng Batang Mandunong, home learning partners, at mga guro na patuloy na nakatutok sa Project SOAR, Series of Online Academic Reviews for Mathematics CLAID Modules, Week 8. Ako po si Ma'am Karen Sota from Andres Bonifacio Integrated School at nagpapaalala sa inyo na kung gusto ninyong maging updated sa mga video lessons, huwag pong kalimutang bisitahin, i-like at i-follow ang Mathematics Teachers Association of MANDdunong Math Team Facebook page at i-like, share at mag-subscribe sa MTM YouTube channel. Kanina ay napanood natin ang mahusay na pagbabahagi ni Sir R.C. de la Cruz ng advanced lessons sa Business Mathematics. Ngayon naman, tayo nang tumutok sa huling teacher reviewer para sa araw na ito. Mula sa hanay ng magagaling na Senior High School Mathematics Teachers of MANDdunong. Our last teacher reviewer is a BS Math degree holder from Polytechnic University of the Philippines. He is currently taking up his master's degree at IRIS and is preparing for his final defense. Senior High School, kaway-kaway, tayo nang makinig at magtuto kay Sir Alejandro Bueno Jr. from Mataas na Paaralang Neptune A. Gonzales.
Good afternoon, everyone. Thank you, Ms. Sota, for the wonderful introduction of mine. So our lesson for today is about sigma notation. So the sigma notation is a shorthand for writing sums. So in this lesson, we will see the power of this notation in computing sums of numbers as well as algebraic expressions. Mathematicians use the sigma notation to denote a sum. So the uppercase Greek letter sigma is used to indicate a sum. The notation consists of several components. Let's try to name first the parts of the sigma notation. Let f of m be an expression involving an integer I. So the expression f of m plus 1 plus f of m plus 2 plus ... plus f of n can be compactly written in sigma notation and write it as the summation of f of I from I is equal to m to n. So n is the upper bound, f of I is the summand, m is the lower bound, and I is the index. Again, so we read as the summation of f of I from I is equal to m to n. So let's have some example. Okay, so some example. So express the series using the sigma notations. So number 1 here we have 1 plus 2 plus 3 plus 4 plus 5 plus 6. So we need to rewrite that into sigma notation. So as you can see, nakikita nyo naman na yan ay pabilang ng pataas. So I mean dire-diretso siya. 1, 2, 3, 4, 5. Continuous. Ganun. Continuous. So, therefore, pwede natin siyang gawing sigma notation. Dahil ganyan lang siya. So, the sigma notation, 1, 2, 3. From, ang magiging lower bound natin or the lower limit natin is 1. So, we can say that I equal to 1. And upper limit natin is yung 6. 6. So 1, 2, 3, 4, 5 to 6. Ibig sabihin, the summation of 1, 2, 3, 4, 5, 6, for which is, let's say that is our I. Okay? So, if I is 1, I is 2, I is 3, I is 4, I is 5, I is 6. So, there you go. So, we have I, the summation of I from I is equal to 1 to 6. Next example. So, tingnan natin mabuti. So, titignan na tayo ng series dyan. Series, it means series naman talaga. So 1 plus 4 plus 10 plus 16 plus 16 plus 21 plus 36. So makikita nyo, para sila ay perfect square. So ang 1, pwede natin isulat dyan as a perfect square na y squared. Plus this one is 2 squared. So I 3 squared plus 4 squared plus 5 squared plus 6 squared. Okay? So meron tayo na parang doon sa taas, 1, 2, 3, 4. So therefore, ang summation natin is the summation of ang lower limit, let's say I, from 1 hanggang kay upper limit natin is 6 or lower bound natin is 6. 1, 2, 3 is I. Constant yung kanyang power. So that is I squared. Okay? Ang changing lang is yung si I. Okay? Another example. Okay? Okay, example number 3. So we have 2 plus 5 plus 10 plus 17 plus 16. Again, express it into sigma notation. So, titingnan natin kung paano tayo makakakuha ng I. Paano ba? So we have 2 plus 5 plus 10 plus 7 plus 16. So, ano ang kanilang pagkakaparehas? Wala yata. Okay? So, dito, pag nag-minus tayo ng 1 dito, magiging 4. Okay, plus tayo. Ito. So, pwede tayong magkaroon dito ng 1. Tapos dito is 4. Dito is 9. Dito is 16. Dito is 25. Yan. 25. So, pwede natin group. Yan. Yung 25. Yan. So, parang yung sa example natin na example number 2. Example number 2 natin, no? So, lahat sila perfect square. No? Perfect square. So, para maging 5 yan, we must add 1. Ito, para maging 1 yan, maging 2 yan, add tayo ng 1. So, lahat, add tayo ng 1. Okay? So, ang ano dito, nakakuha tayo ng pattern doon sa example number 2 natin, which is yung example number 2 natin. So, lahat sila perfect square. So, pwede natin sabihin dito ay 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1. Yun. Okay. So, equal din naman, di ba? Equal. So, meron tayo. So, therefore, ang sigma notation natin is the summation of I, no? Yung I natin is, yung sa example number 2 natin is from 1. Tapos, ang upper bound natin is hanggang 5. Hanggang 5. So, ang summand natin, ito, yung summand natin is from I squared plus 1. So, ito is example number 2, nag-add tayo ng 1. Okay. So, the summation of parenthesis I squared plus 1 from I is equal to 1 to 5. Okay, let's check kung tama nga. Pag I is 1, squared 2, okay. Pag 2 yan, so hanggang 5, okay. Good, correct. Final answer. Okay. Number 4. So, tingnan natin. 1 plus 2 plus 4 plus 8 plus 16. So, anong common nila? So, dito, multiple of 2. They are all multiple of 2. So, paano kaya ito mamaya? Tingnan natin muna. So, multiple of 2 yan. Ito, pwede natin i-rewrite into exponential form, which is 2 to the first. First, para lang makita natin. Ito, 2 squared. Ito is 2 cubed. Ito is 2 to the fourth. So, meron tayong 1, 2, 3, 4. So, ano si 1? So, sa exponential equation natin, one property doon is any real numbers raised to 0 is equal to 1. So, therefore, pwede natin gawin itong exponential form equal to the base of this. So, we have 2 to the 0, which is equal to 1. So, there you go. Meron tayong pattern, no? So, the summation niya, magiging lower limit natin is the 0, and the upper limit is hanggang 4. So, ang summand mo is I, 2, the constant 2 I. So, I is the changing one, from lower limit to upper limit. Integer only. Okay. Check natin. 0, 1, 2, 3 hanggang 4. Okay, very good. Final answer. Another example. Okay. Last 2 examples. So, first natin yung 5. Last 2 examples. So, we have here is negative 1 plus 2 minus 3 plus 4 minus 5. So, paano natin siyang isusulat into sigma notation? Nakita ko lang sa example to sa natin. Ay. Okay. Negative 1 plus 2. So, meron tayong 1 plus 2. Let's say 3. Kaso, negative yun. Ito negative din. Okay. Meron tayong 1 times negative 1 plus 2 negative 1. Dapat to positive. Okay. Pwede yan. So, pwede natin gawin to na squared. Or, 1. So, negative 1 raised to 1. Okay, negative 1. Very good. Tayo dun. Okay, 2. Negative 1. 2 squared. So, magkakaroon na tayo ng, again, dalawang index natin to lower limit to upper limit. So, 1 ito plus 3 times negative 1 cube. So, even negative 1 plus 4 times negative 1 to the 4th. Okay. Plus 5 negative 1 to the 5th. So, rule natin sa exponential equation, exponential expression, one of the rule there is kapag ang base mo ay negative at ang exponent mo is odd numbers, final answer is always negative. Pag even number naman, is always positive. So, magiging positive to, 2. Ito magiging negative. Okay. So, the summation, 1, 2, 3, 4, 5. So, ang index natin ngayon ay from 1 to 5. Sakto. To 5. So, samahan natin. Ang changing natin sa index natin, the lower limit natin is yung sa baba. 1, 2, 3, 4, 5. So, magkakaroon ng I. Constant natin is negative 1. Constant, 1. And again, ang I natin, exponent. So, that is the summation of I times negative 1 raised to I from I is equal to 1 to 5. Checking. Okay, final answer. So, yung last example natin is very tricky. I want to show you na yung expressing the series into sigma notation is necessarily not unique. Hindi sa unique. Okay? Example number 6. Okay? Example number 6. So, meron tayong 1 plus 1 half plus 1 fourth plus 1 8 plus 1 over 16. Doon sa example number 2 natin, magkakaroon tayo ng pattern dito sa baba. No? Sa baba. So, lahat sila ay multiple. Example number 2 ba? Example number 3, I think. Example number 3. Meron tayong multiple of 2 or lahat sila can be written into exponential form having a base of 2. So may common din sila, no? So paano ito? So let's mamaya yan. So we have 1 to the first plus ito ay 2 to the second plus 1 over 2 cube plus 1 over 16. 4 squared. 4 squared. 2 to the 4th. Sorry. So, meron tayong 1, 2, 3, 4. Ang constant natin is 2. How about yung 1? Magkakaroon tayo dyan ng, again, 2 to the 0. So, pattern natin, yung example, may example natin yung previous, wala pa yung number na yan. So, 1, 2, 3, 4. Okay. So, the summation ng magiging index natin dito ay is equal to 0. 0 from 0 to 4. Yan. 0 to 4. So, summand natin is 1 over 2 the I. Okay? So, pwede rin siguro since hindi, I think gusto ko ipakita sa inyo na hindi unique yung not necessarily the sigma notation of the sum of expression is not necessarily unique. Hindi siya unique. Pwede rin natin sabihin from 1 to or pwede rin pwede siguro itong summation ng I equal to 1 to 4 bali 8 na 5 na plus 1, 2, 3, 4, 5 1, 2, 3, 4, 5 5 terms. So we have 5 terms. So from 1 over 2 to the k minus 1. Pwede na. I minus 1. Pwede. No? So, pag I is 1, magiging 0. Yun pa rin. Pag I is 2, 1. 3, 2, bawas. Okay. Pwede. So, There you go. So expressing the series using sigma notations, example 1 to 6. Have you learned something? Pero meron pa tayong isa. Meron pa tayo. Vice versa naman yan. Sigma notation into samahan or into what do you call that? Expanded form. Expanded form ng sigma notation. Okay, so next topic natin is to expand the summation and simplify if possible. Ito, example natin. So, expand each summation and simplify if possible. So, number 1 natin. So, dito, sa expanding lang naman ang summation natin is we need to know o kailangan natin malaman yung number of terms o yung summand natin, yung number of terms niya, kung ilan. So, makikita natin dyan, dun sa value ng index mo o sa lower bound mo hanggang kay upper bound o the upper limit. Iba kasi tawag. So, 1, 2, 4. So, ang gagawin natin para malaman natin is subtract natin yung upper bound minus kay lower bound plus 1. So, ito yung number of terms. Number of terms. Okay? So, ang number of terms natin, since 1 naman yan, automatic 4 yan. So, pag natin 4 minus 1 plus 1 is 4. So, yung summand natin is 4 terms. Okay? Baka kasi sumobra kayo. Okay, balik tayo. So, we have 2 substitution. Ang first value ng I natin is 1. So, that is times 1 plus 3. Okay, continue lang natin. So, 2 times 2 plus 3 plus plus 2 2 times 3 plus 3. Yeah. Plus is 1, 2, 3, 4. 4 terms. So 2 times 4, which is yung 4 is yung last ng yung upper last value ng upper bound. 4 or value ng upper bound mo, sorry. Plus 3. Okay. So, equivalent yan. Pwede natin yan i-simplify. So, 2 times 1 plus 3. 2 times 1 plus 3 is 5. Plus 2 times 2 is 4. Plus 3 is 7. Plus 2 times 3 is 6. Plus 3 is 9. Plus 2 times 4 is 8. Plus 3 is 11. So, 5 plus 7 is 12. Is 21. Plus 9 is 21. Plus 11 is 33. So, the summation of 2i plus 3 from I is equal to 1 to 4 is equal to 30. Okay? Let's go. Example number 2. Para ulit malaman natin yung number of terms, yung upper bound minus natin kay lower bound plus 1. Okay? So, ilang terms kaya ito? So, 5 minus negative 1 is 6 plus 1 is 7. So, we have 7 terms. Sabi yatang marami. Bawasan natin. Bawasan natin. Kahit ito lang. Yan, 2. So, we have 2 minus 1, 2 minus negative 1 is 3 plus 1 is 4 terms. So, we have 4 terms. Okay? So, start tayo. So, we have 2 minus 3, which is case negative 1. Start ng negative 1. Plus 2 minus 3, negative 1, then 0. Okay? 0 plus 2 minus 3 times 1 plus 2 minus 3 times 2. So, yung last mo, yun yung value sa upper bound. We can simplify this. Okay. Yes, we can. So 2 minus 2 times negative 1. So negative 3 times negative 1 is positive 3 plus 2 is 5. 5 plus negative 3 0 plus 2 is 2. Negative 3 times 1 is negative 3 plus 2 is negative 1. Plus negative 3 times 2 is negative 6 plus 2 is negative 4. Tama ba? Okay. 5 plus 2 is 7 minus 1 is 6 minus 4 is 2. The answer is 2. Final answer. Okay, example number 3. So, expand the summation of a to the I from I is equal to 1 to n. So, ang lower bound mo is 1. So, start tayo ng 1. Okay. So, we have A, then 1. Plus susunod dyan is 2. Plus A sub 3 plus so that na lang natin hanggang kay upper bound A to the n. We cannot expand that. We cannot simplify. Hindi natin pwede simplify. Final answer na to. Done. Okay? So we have here the properties of sigma notation. But before that, so we start with finding a formula for the sum of summation of I, where I is from I is equal to 1 to n. So, dun sa previous lesson natin, topic natin, this one is equivalent to, when we expand, this one is equal to 1 plus 2 plus 3 plus blank 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 n. So to get the sum in fastest way, you can use the sequence sa arithmetic series nyo na S sub n is equal to n times a sub 1 plus a sub n all over 2. Pero dito, we can do that na n times n plus 1 all over 2. So, mas madali natin makukuha yung kanyang sum using this formula. Example tayo, summation ng I or I is equal to 1 to, let's say, 5. Since mababa lang naman, applicable yan sa matataas. Check lang natin. So we have 1 plus 2 plus 3 plus 4 plus 5. Equivalent yan sa 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. Okay, very good. So using the formula, so n natin is 5, that is 5, and 5 plus 1 over 2. So 5 plus 1 is 6 times 5 is 30, divided by 2 is 15. So the same. So we can use this as we can use the formula in finding the summation of I, where I is equal to 1 to n. Okay? So proceed tayo sa first property. So first property natin is the constant. So summation ng constant from I is equal to 1 to m to n. Okay? So you can see, so summation ng C, pag in-expand natin yan, that is C plus C plus C plus dot C. So take note, ito ay number of terms. So to get the number of terms, yung sinabi ko sa inyo, we need to subtract m from n. So that is n minus m plus 1. So this is the number of terms. Okay? So therefore, equivalent answer is C times n minus m plus 1. So example tayo. Summation ng 3 from I is equal to 1 to 4. So ang constant natin is 3. Or take note, doon tayo sa sa pinaka yung long method. So we have 3. So 1, 2, 3, 4. We have 4 terms. 1, 2, 3, 4 terms. So 3 plus 3 plus 3 plus 3 is 12. So using this formula, so we have constant 3. Ang n natin is 4 minus m natin is 1. 1 plus 1 is equal to 3. Same lang. Okay? Pang vice versa din, kunwari naman is 10. 10 plus 10 plus 10 plus 10. 1, 2, 3, 4, 4 terms. So equivalent niya pag sinamin natin yan, yun na. 1, 2, 3, 4. So we have I equal to 1. 1, 2, 3, 4 is to 4. Okay. Yan yung equivalent namin. Pag summation. So second property natin, second property natin is the summation ng C times f of I, where I is to from I is equal to M to N, and C is a real number. Okay. So equivalent yan. Equivalent yan kay C, summation ng F I, or I is equal to M to N. Okay. Third, next property. Yung summation ng F of I plus G of I from I is equal to M to N. Equivalent yan kay summation ng F of I from I is equal to M to N, plus summation ng G of I, same din, from I is equal to M to N. Pwede naman. Same din sa minus. And summation ng F of I minus G of I, where I is equal to M to N. Equivalent yan. So like that. Parang ganun din. So summation ng F of I is equal to M to N, minus summation ng G of I from I equal to M to N. Okay? So, yun muna ang mga property natin para ma-follow natin yung activity nyo sa module. Okay? So, let's have some example. Okay? So, evaluate sum. So, first example natin is summation ng 6 I is equal to 1, 2, 3. So kung makikita nyo, yung upper bound natin, medyo konti lang. So medyo okay lang kung di natin gagamitin yung property. So, long process tayo. So, bilangin lang natin yung terms. So, 3 minus 1 is 2 plus 1 is 3. Pag 1 yung lower bound mo, automatic, yung what do you call that? Yung upper bound mo, yung number of terms mo. So, we can multiply that 6 times 3 kaagad. Okay? So, pwede rin naman 6 plus 6 is equal to 18. Okay? Or, yun nga sinabi ko, since 1 naman ito, 1 yan, pwede natin sabihin 6 times n. Okay? 6 times n. Or 6 times 3, sorry. 6 times 3 is equal to 18. Yung formula natin na constant times upper bound minus the lower bound plus 1. Pwede ng 6 times 3 minus 1 plus 1 is equal to 8. Pwede, kahit saan dyan. Kung maliit naman yan, pwede ka nang gumamit ng long method. Paano pag ganito? So, summation ng 2 for I is from I is equal to 1 to 50. Yan, sabi ko. So, kailangan na maglagay ka ng 2 plus 2 plus 2 plus 2 plus 2. So, pwede natin gamitin yung property. So, property natin, the constant multiplied by the number of terms. So, number of terms natin is 50, the upper bound minus the lower bound, which is 1, plus 1 is equal to 100. So, dyan naman nagagamit lang yung pagmalaki na masyado. At yung I mo, for example, is nag-start sa 3. Yan. Pwede yan. Next example natin. Evaluate natin yung summation ng 4i minus 15. Yan. 4i minus 15. From I is equal to 1 to 120. 120. So, pwede tayo, dito natin i-apply yung ating properties. So, yung one property natin, pwede natin i-rewrite into summation ng 4i from I is equal to 1 to 120 minus summation ng 15. Yan. Summation ng 15 from I is equal to 1 to 120. I-rewrite natin. So, ito rin, pwede natin i-rewrite sa another property natin for which is summation ng 4, summation ng I, where I is equal to 1 to 180 minus meron tayong I natin is 1, nag-start sa 1, so pwede natin mag-direct ng constant times the upper bound. Yan. So ito naman is 4, summation ng I from I equal to 20, for which is equal to yung formula natin na gagamitin natin dito is yung n times n plus 1 all over 2. So thus ang n mo is 120 times n plus 1, so 121 all over 2 minus 15 times 120. Calculator natin. Ano po ang calculator? So, 4 times 120 times 121 equals to divided by 2, 29,040 minus dun sa 15 times 120 to 100,800. So 29,000 29,040 minus dun sa 1,800 equivalent yan 27,200. Kaysa naman yung gagawin nyo na substitute nyo yung 1 hanggang 120. Napakahaba nun. So, by using the properties, pwede nating makuha agad yung sum. Sa module nyo, is mga small numbers naman, so pwede na siguro yung ilang process. Pero pag mga mahahaba, make sure na gamitin yung properties para hindi kayo mahirapan. So, yan muna sa ngayon. Salamat sa panonood.